Uniform motion is described as an object that displaces an equal distance in an equal amount of time. For example, let's take a look at this car. If you watch closely, you'll notice that for every 1 second of travel, the car displaces or travels 10 meters. This vehicle, on the other hand, does not travel uniformly. For every 1 second, it seems to travel a different distance. For the first second, 10 meters. The second second, 20 meters. The third second, 30 meters. And finally, the fourth second, it seems to travel 40 meters. This ball is an example of uniform motion. For every 1 second of time, it displaces 20 centimeters to the right, denoted with the positive 20. If we collect the data from this rolled ball across the floor, this is the table. For every 1 second interval, the position seems to increase by 20 centimeters to the right. For each 1 second time interval, the change in position, also known as the displacement, is 20 centimeters to the right. If we graph the data as position versus time, where position is the dependent variable and time is the independent variable, you can see we get a straight line. A straight line on a position time graph is a positive indicator of uniform motion. It displaces plus 20 centimeters per second. If we have a straight line on a position time graph, the slope provides us with some useful information. If the slope is positive, then it indicates that the object is moving in a positive direction. Recall that up, to the right, north, and east are often denoted as a positive direction. If you have forgotten this lesson, go review the vectors video. In the example below, the object starts at a relative point 0 and moves to the right. An animation to illustrate this would be the ball moving to the right. If you have a zero slope, a straight line that is perfectly horizontal, that indicates that there's no change in position with time. The object is simply at rest. In our example, the object stays at 2 meters to the right of a relative point and does not move. An animation for this would be a ball which stays in a fixed position for the 5-second duration. If you have a straight line with negative slope, it indicates an object that is moving uniformly in a negative direction. In the example below, an object starts to the right of a reference point and moves left towards the point and eventually will pass the reference point. An animation for this would be simply a ball moving to the left. What is a real-life example of a position time graph like our last example? An example of this might be a golfer who has a ball at rest 1.5 meters to the right of the hole. He putts it and it approaches the hole and passes the hole and continues to move past it to the left. Take a look at this example. Line 1 represents an object starting at a reference point or the origin and moving north. Recall north is the positive direction. It will travel 3.5 meters in 5 seconds. Line 2 represents an object at position negative 2 meters north. Negative represents the opposite of north, south. So the object will start 2 meters south of the reference point and move to half a meter north of the reference point in 7 seconds. Line 3 represents an object starting at 2 meters north of the reference point and move to 1.5 meters south of the reference point over a 7-second duration of time. Finally, line 4. Line 4 represents an object starting at 0, the origin, and moving in the negative direction, south. It will move 3.5 meters in 4.5 seconds. Take a look at this position time graph. It has a series of straight lines on this position time graph, which indicates that the object travels at uniform motions for components of the graph. For the first 6 seconds, the object will move north 2 meters. From time 6 to 10, 4 seconds, the object remains stationary, or at rest. From time 10 to 12, the object will move from 2 meters to 6 meters north. Between time 12 and 14, the object will return to its origin. It will travel in a negative direction, south. Between time 16 and 18, horizontal line, the object remains at rest. And finally, between 18 and 20 seconds, the object at the origin will move in the negative direction south 2 meters in 2 seconds.